Yes, good afternoon, dear friends. Yes, we can continue last class continuation. Oh, only one student joined. Okay, right. Only two students joined. Oh, okay, we can start. Here, second block, unit number 10. Operational amplifier frequency. Operational amplifier frequency. Okay, na? In this one, most important thing is open loop frequency response and closed loop frequency response. These two are very, very important topics. So in that, first we'll discuss about the open loop frequency response. Open loop frequency response. Yeah. In this one, consider operational amplifier which consists of a series combination. Okay. Consider as a output impedance is a R naught, input impedance is a Rn, or else a small r. Such kind of thing. Every operation amplifier output R naught, that is goes to next operation amplifier input. In that input impedance is a small r. That one is a compressed diagram I'm taking here. Equivalent Diagram for open loop frequency response operational amplifier. This is a input resistance. One input is a V1, other input is a V2. V1, V2. Okay. Input resistance is smaller. Here is a voltage gain, that is a AV. The thing is here output resistance which is connected to the here across the output terminal. This is a R naught. Then here you can give the connection is ground. Other one you can give the parallel capacitor. Here this is a C. So why you are here connected the in the output combination resistance is a parallel. One second, time up. One second. I got one message. I started class. Hello. I received one message from BRAU Hyderabad main center. Sir, I started class already. Yeah, it's okay. Yes, it's okay, students. Right. This is a capacitor connected to the output resistance in the parallel. Why we are connecting capacitor in the parallel means when the capacitor work is to store the energy, na? So store the energy purpose only we'll use the capacitor. The capacity connected in the parallel means automatically the output value, magnitude value, it can strength increases. So large value measuring purpose will connect the capacitor in the parallel. These thing they can ask in the Viva in the practical also. Across the output resistance only in parallel combination the capacitor is connected. Okay, right. Now we can use here voltage divider rule. Means voltage splitting the rule. That is called as a voltage divider rule. Then we can find write down here equation. Output voltage is equal to minus J into reactance of capacitor, that is a XC, by R naught plus this one reactance of the capacitor into J. So minus J into XC. That voltage is the input voltage. Like V is equal to IR type only. Voltage across that output thing is A into VI. Nothing but V in. VI. This is in, this is out. Where XC reactance of capacitor. It means the resistance offered by the capacitor. The resistance offered by the capacitor is called as the reactance of capacitor. That value XC is equal to 1 by omega C, actual thing is. Again, omega is equal to 2 pi f. Then 2 pi f into C. It will be there in a degree and intermediate standard. Okay, na? And here the thing one more. You can written as minus j is equal to 1 by j, the coefficient type. Okay, na? This value is xc value minus j value, you can substitute in this equation. You can get modified equation. Then v naught is equal to, instead of minus j, 1 by nothing but xc only now. Xc value 1 by 2 pi fc. Then we'll get here 1 by 2 pi fc, that is xc value, minus j value is a 1 by j. So it will be j additionally. 2 pi fc into j, or j into 2 pi fc, whatever may be. In numerator, a into vi, a vi, like here capital A v suffix I, divided by r naught, as it is r naught only, r naught only. Again minus jxc, same this one only repeated. So we'll get here plus 1 by 2 pi fc into j. Now we can simplify this thing. You can take LCM in denominator 2 pi fc into j, 2 pi fc into j. So we'll get here v naught is equal to this 2 pi fc into j, 2 pi fc into j get cancelled. Then we'll get AVI or A into VI, whatever may be. Okay, no? A is a gain, VI is the input voltage. Better we can write in the proper way like this. AVI. So AVI divided by, I'm going to cancelling here directly. 2 pi fc into j, 2 pi fc into j. You can do the cross multiplication here. 2 pi fc into j plus into r naught plus 1 plus 1. From that you can written as v naught by vi is equal something. Cross multiplication, v naught by vi is equal to a by 2 pi fc into j r naught plus 1. But we know voltage gain a naught is equal to v naught by, sorry, v naught by I, v naught by vi. Instead of v naught by vi, it can written as a naught. So in this equation, it can modify like this: a naught is equal to a by 2 pi fc into j r naught plus 1. Okay. Now we can here assume, here assuming 1 by f is equal to 2 pi c into r naught. 2 pi c r naught value I'm considering here is a 1 by f. Then you can substitute here. J by f. 1 second. This already f is there. Then we can assume it is to f1. And the 2 pi c r naught value can take it as 1 by f1. Then we'll get f into j by f1 will get. That thing I will write here. Is it okay now? Few sentence they printed mistakenly in this answer in the textbook, you can cross check. Addition, multiplication, they did small mistakes. Numerator value denominator numerator lo print chesadu. Okay, check cheskondi. Then we'll get here a naught is equal to a by, instead of 2 pi c r naught 1 by f1 is j into f by f1 plus 1. Okay, no? This is a naught value. If you want to calculate magnitude of a naught, magnitude of A naught will be get mod. Mod A naught is equal to will get A by under root of J square value will get 1. Then we'll get 1 square plus F by F1 whole square. J square value also 1. Okay, na? If you want to calculate your phase angle theta is nothing but tan theta, slope. Phase angle nothing but tan theta. Tan theta is equal, we'll get opposite side by adjacent side, then we'll get F by F1. So from that, if you want to calculate theta, then tan inverse of F by F1. So from this, you can go through the diagram part. Graph. Once note down the points. Okay. Hmm. From this, you can observe the graph. Graph between magnitude of A naught and frequency. On x-axis, you can take it as frequency, and magnitude of that is A, gain, voltage gain. Voltage gain A naught. Okay, no? So in that one, graph nature will get slightly first parallel to the x-axis, then slightly decreases, then it goes like this, cut up curve type. At this position, we'll get maximum frequency, that is, you can say the F1. In open loop circuit, you'll get a closed frequency FC versus a voltage gain graph. The graph nature is like this, will get a thing. Frequency may be 10 hertz, 100 hertz, 1000 hertz, whatever may be the range. And gain values in terms of measure in terms of dB, decibels. This value measure in terms of decibels. This frequency measure in terms of hertz. Okay, na? That's a graph nature. Similarly, same thing. You can observe closed loop frequency. Same thing, closed loop frequency also. Okay, na? Closed loop frequency response. Next one. That thing you can do yourself. From this open loop and closed loop, out of these two, 99% you can expect any one damn surely. Okay. Once you can see page number 154, there is a closed loop frequency response. Given the closed loop frequency response, general expression, feedback gain is equal to A naught by 1 plus beta into A naught, where beta into A naught is the gain around the loop formed by the amplifier and the feedback network. Again, you can substitute A naught value. We know already in the previous condition here A naught value. A naught value A is A naught value A by 1 plus J into F by F1. That value you can substitute here. You will get automatically directly answer. Not complemented. But in the closed loop frequency response condition, we have to remember previous open loop frequency response voltage gain A naught value. That is A naught is equal to A by 1 plus J into F by F1. That one we have to remember it. That value can substitute here. Directly we'll get answer. Okay, na? These two are most important things. Only these two things only important in this one. Or else sometime they will ask. Difference between closed loop and open loop operation amplifier. Sometimes they will ask that difference also in the short answers. But maximum case in 10 markers, open loop gain or closed loop gain, they will ask in the examination point of view, one check it. Is it clear? Right. So in this unit, important questions, both the sections, first questions only is enough. Both the sections, first question only is enough. Then next we can go to next unit, that is a unit number 11. One second. Next unit 11, operational amplifier, simply OAMP, operational amplifier, linear applications. With help of these operation amplifiers, we can do the summation, subtraction, integration, and differentiation. These all the things. In that one, first with help of operation amplifier, I'm going to doing here summing, nothing but addition. Summing amplifier. First one is a summing amplifier. Nothing but addition. In the summing of operation amplifier, we'll take inverting operational amplifier first. Inverting operation amplifier means the positive terminal is connected to ground. The IC number is a 741 is called as a operation amplifier. Okay, this is connected to the ground. Next, negative terminal connected to the input. In that input here, they can consider 4 resistors or 3 resistors, that is based on the possible combinations. So I'm taking here 3 input resistance, R1, R2, R3 are connected in parallel. That input resistance R1, R2, R3 are connected in the parallel combination. Okay. For this one, voltages V1, V2, V3. One terminal is V1, V2, V3. Other terminal is connected to ground only. Always potential difference measure across the 2 points only. Current across the R1 resistor is a I1. Current across the R2 resistor is a I2. Current across the R3 resistance is a I3. Okay, na? Right. Next one, this junction is a ES junction. Generally, we consider in the previous one only. Voltage here is a Vs. This voltage is a Vs. Again, this is connected to the feedback, giving feedback to inputs. This is a here V naught, giving a feedback. So that is called as a RF. So here current is a IF, feedback current, feedback resistance. Okay, right. Now we have to find out here current. IF is equal to I1 plus I2 plus I3 na, according to Kirchhoff first law. According to KCL, Kirchhoff law, I1 plus entering current equal to leaving current at the junction. At the junction, entering current is I1 plus I2 plus I3, that is equal to IF. We don't know I well directly. Then we can take in terms of voltage and resistance. Because we know voltage across these things V1 minus Vs, V2 minus Vs, V3 minus Vs, resistance R1, R2, R3. From Ohm's law, V is equal to IR, I is equal to V by R. Na. So instead of I1, we can take it as V1 minus Vs by resistance R1 plus V2 minus Vs by resistance is R2 plus V3 minus Vs by resistance is R3. That is equal to IF. Voltage, that is a Vs minus V naught by resistance is a RF. Okay? Directly this is adding addition only. Na? Adding. If you say the voltage instead of V1 minus Vs, that is a voltage you can consider as a V1. If you give the ground connection, that voltage difference. V1, V2, V3, then you can say the V1, V2, V3 something. I'm clear. These are parallel, na? Voltage remain constant. So it can be written as V1, V1 by R1 is there now. If all the resistors are, you can consider ideal, then you can cancel. Then V1 plus V2 plus V3. ಇದೆಲ್ಲ ಅರ್ಥಮೌతుందా? I'm taking Vs terminal is connected to 0. Then R1, R2, R3, RF is equal. I'm taking identical resistors. Then it can be cancel R values. Then we'll get V1 plus V2 plus V3 is equal to here Vs value, the voltage between these two. Here this is a voltage. In series, it won't constant. In parallel only it can constant. LHS side V1 plus V2 plus V3 okay, but RHS side will get it as here feedback na, that is a reverse. Sum of the all voltages, that is a V naught okay na. లేదనుకుంటే మన లోకల్ వేలో కూడా చెప్పొచ్చు. మనం అనుకున్నట్టు ఎందుకు R1 ఈజ్ ఈక్వల్ R2 ఈజ్ ఈక్వల్ R3 ఈజ్ ఈక్వల్ RF అని సేమ్ ఉన్నాం. VS కనెక్టెడ్ 0 టర్మినల్ ఉన్నాం. అప్పుడు V1 ప్లస్ V2 ప్లస్ V3 ఈజ్ ఈక్వల్ V నాట్. ఇంకా సింపుల్ గా వితౌట్ కన్ఫ్యూజన్. అది బెటర్ కదా ఇక్కడ. VS I'm considering 0. R1 is equal to R2 is equal to R3 is equal to RF. Blind గా రాయొచ్చు కదా. దట్ ఇస్ బెటర్. దిస్ వే ఇస్ బెటర్. ఓకేనా? అంటే ఏమిచ్చి మన సమేషన్ ఆల్రెడీ మనకు తెలుసు కదా సార్, సిరీస్ లో ఉన్నప్పుడు వోల్టేజ్ ఎఫెక్ట్ ఈక్వలెంట్ వోల్టేజ్ ఈజ్ ఈక్వల్ సమ్ ఆఫ్ ఇండివిజువల్ రెసిస్టర్ వోల్టేజ్ కదా. అదే సమ్మేషన్ చేస్తుంది మనం. అక్కడ నార్మల్ గా అనలిటికల్ గా చేసాం, ఇక్కడ విత్ ఆపరేషనల్ యాంప్లిఫైర్ నుంచి సమ్మింగ్ చేస్తుంది. అంటే విత్ ఆపరేషన్ యాంప్లిఫైర్ సమ్మేషన్ వాల్యూ ఆల్సో సేమ్, నార్మల్ సమ్మేషన్ వాల్యూ ఆల్సో సేమ్ అని ప్రూవ్ చేసినట్టు మీనింగ్. ఓకేనా? దట్స్ గుడ్. Then when it is split in the parts, then all the volt resistors are same, then voltage can dividing across the all three resistors will be same only. That is a V0 by 3, V0 by 3, V0 by 3, V0 by 3, V0 by 3. Total లో by 3 by 3. అదేవిధంగా సిమిలర్ గా సబ్ట్రాక్షన్ చేస్తే ఇన్స్టెడ్ ఆఫ్ అడిషన్ విల్ గెట్ సబ్ట్రాక్షన్. ఒకవేళ 3 ఉన్నాయనుకో అప్పుడు V3 minus V2 minus V1. ఓన్లీ 2 ఉన్నాయనుకో V2 minus V1. Okay, maximum case in the subtraction cases of resistors will consider only 2 to only maximum cases. Then difference in voltage is equal to V2 minus V1, which is higher. That higher minus least value only. Understanding what I'm telling? Subtraction అయితేనేమో subtraction చేయాలంతే with help of amplifier. Addition అయినప్పుడు ఏం చేసాం మనం? యాడ్ చేసాం. సబ్ట్రాక్షన్ అయినప్పుడు ఏం చేస్తాం? డిఫరెన్స్ తీసుకుంటాం. That is called as differential operational amplifier. He given 2 steps clearly in textbook. You can go through it once. Page number 160. Is it okay? Okay na? Output voltage V0 is equal to V2 minus V1 in subtractor. Right. The next third one, integrator. Integrator, the next differentiator, I will explain. Basic comparator, then enough. So first, summing nothing but addition. Next one is a subtractor. Third one integrator. Fourth one, differentiator. Fifth one, basic comparison. There is a basic comparison or basic comparator. ఇవి అడిగితే ఇండివిజువల్ గా 5 మార్క్స్ అడగొచ్చు. అప్లికేషన్స్ ఓపెన్ లుక్ క్లోజ్ లుక్ అయితే 10 మార్క్స్ లో, సమ్ టైమ్ ఎప్పుడన్నా అడిగితే కూడా 5 మార్క్స్ లో కూడా అడగొచ్చాము పేపర్ టెస్టింగ్ చేయాలనుకుంటే. థర్డ్ అప్లికేషన్ ఈజ్ ఇంటిగ్రేటర్. ఇంటిగ్రేటర్ ప్లస్ మైనస్. హియర్ థింగ్ ఈజ్ a V naught. హియర్ ఇన్పుట్ రెసిస్టెన్స్. ఇన్వర్టింగ్ కాబట్టి అన్నిట్లో పాజిటివ్ టర్మినల్ గ్రౌండ్ కి ఇచ్చేస్తున్నాం, అది ఇన్వర్టింగ్. ఇది V1 అనుకోవచ్చు, ఇది V2 అనుకోవచ్చు. ఈ జంక్షన్ చేసుకుంటే ఇక్కడ వస్తుంది పాయింట్ ఎస్. ఇక్కడ వస్తుంది ఇన్వర్టింగ్ దాంట్లో. ఇది వరకు అయితే ప్రీవియస్ ఆల్ ద కేసెస్ లో రెసిస్టర్ తీసుకున్నాం, ఇప్పుడు కెపాసిటర్ తీసుకుంటున్నాం ఇంటిగ్రేటర్ లో. అంటే కరెంట్ అక్రాస్ కెపాసిటర్ హ్యావింగ్ ప్లస్ మైనస్ ప్లేట్స్ నా, we have to calculate the current across the capacitor is IC. అక్కడ ఫీడ్బ్యాక్ రెసిస్టెన్స్ RF అన్నాం, ఇక్కడ కెపాసిటర్స్ కాబట్టి C. కరెంట్ అక్రాస్ ద కెపాసిటర్ ఇస్ IC. ఫ్లో డైరెక్షన్ లైక్ దిస్, పాజిటివ్ ప్లేట్ టు నెగటివ్ ప్లేట్. ఓకేనా? రైట్. This is a base terminal current I'm feeding, this is a IB. This I'm taking I in. Again you can apply Kirchhoff according to KCL, Kirchhoff first law at a junction. Yes. Entering current is II, input current, equal leaving current IB plus IC. First we can calculate current through the capacitor. Oh, we know that current through the capacitor in degree standard, I is equal to C into dV by dt. ఇంటర్మీడియట్ అయితే ఉంటుంది. EM waves లో, ఎలక్ట్రోమాగ్నెటిక్ వేవ్స్ లో డిస్ప్లేస్మెంట్ కరెంట్ అండ్ కండెన్సర్ కరెంట్ అని వస్తుంది. IC is equal to C into dV by dt. We know that. We know that IC is equal to C into dV by dt. So from this we can written as delta V value across these two. IC అంటే ఇదే కదా, ఇక్కడ వోల్టేజ్ డిఫరెన్స్ తీసుకోవాలి. Is not but same thing only, V naught. We can written as here dV is equal to Vs minus V naught. So I can substitute here that value. Okay na? IC nothing but input current. First you can write here IC is equal to C into Vs minus V naught by dt. Here this values you can substitute in the first equation. From this equation, here the thing is IB is a very small, that is approximately equal to 0. Maximum current flows through a capacitor only. It won't go magnitude of maximum magnitude of current across the negative terminal of amplifier. So small current, that is I'm taking negligible current IB. Automatically that implies II is equal to IC. II value input current VI minus VS by R in, or else input resistance ఏది R in R1 RIO ఏది అనుకుంటుంది, I'm considering RI. That is equal to IC. IC is equal to C into Vs minus V naught by dt. From that you can calculate V naught is equal to something. V naught is equal to something and find out here. One second. If you give the here zero voltage, if Vs is equal to 0, that equation can modify the at point S is connected to the ground. Then you can say if Vs is equal to 0, this equation can modify Vi by Ri is equivalent to minus C into V naught by dt. Then is there any possibility? From that we have to calculate V naught in terms of R, C and Vi. Do cross multiplication. C V naught Ri is equal to Vi into dt na. I want to use అవుతుందా? We have to calculate here V naught only. V naught is equal to Vi by C into Ri into dt. We can do the differentiation, sorry, integration. Why? Because we said integrator అన్నప్పుడు integration చేయాలి, differentiator అన్నప్పుడు differentiation చేయాలి. So we have to do the integration part only. Where should I do integration? If you do here integration, I will get a integrating on both side. Integrating on both side. Integrating with both side with respect to their terms. Integration 1 dv v వస్తుంది అట్లా విత్ రెస్పెక్ట్ టైం తీసుకున్నాను అనుకో అప్పుడు ఏమొస్తుంది ఎంత కాన్స్టెంట్ వస్తుంది విల్ గెట్ వి నాట్ దెన్ విల్ గెట్ కాన్స్టెంట్ టర్మ్ RC. Input resistance you can consider as a instead of Ri you can take R only. Then C only. Then 1 by RC integration Vi dt. 1 by RC integration Vi dt. Integration 1 dt Vi కూడా కాన్స్టెంట్ కదా అప్పుడు ఏమొస్తుంది V నాట్ ఈజ్ ఈక్వల్ టు VI by RC నా VI by RC into T. Integration 1 dt T. So integration 1 dt T only. V suffix అంటే ఇన్పుట్ వోల్టేజ్ ఇంటూ టైం బై RC. Output value equal to. This is called as a integrator. Okay na? Next, similarly, differentiator. First note on this thing. Okay na? Okay, na? Then next we can go to differentiator. The next application is a differentiator. ఇంటిగ్రేటర్ లో ఇంటిగ్రేషన్ చేసాం, డిఫరెన్షియేటర్ లో డిఫరెన్షియేషన్ చేస్తాం. One second. Next one is the fourth application, differentiator. Right? You can use again operational amplifier, inverting operational amplifier in this thing. Once you can remember, in integrated, instead of feedback condition, we use capacitor ఇన్పుట్ రెసిస్టెన్స్ లో. ఇప్పుడు ఏం చేస్తున్నాం, ఇంటర్చేంజ్ చేస్తున్నాం. ఇన్పుట్ దగ్గర కెపాసిటర్ ప్లేస్ చేస్తున్నాము, అవుట్పుట్ దగ్గర యాజ్ ఈజ్ రెసిస్టెన్స్. ట్రై టు అండర్స్టాండ్ లాజిక్ హియర్. This is a feedback resistance, which is a capacitor. Here input terminal V1, this is a, you can say the V2. This point is a S. Input current you can say I in. This is a current IB. Current across the feedback resistor, that is a IF. Again, according to Kirchhoff law. According to Kirchhoff law, you can say what we can say. According to KCL, input current equal to II is equal to base of amplifier current plus feedback current IF. So here this II is nothing but a current across the capacitor. Better we can say this is nothing but IC is equal to IB plus IF. IC is nothing but C into dV by dt na. Yeah, dV V1 minus Vs. So V1 minus Vs by dt, that is equal to IB. IB is almost zero only na? Same like in the previous condition type. Across the RF, this value goes to zero only. So IF value, I can say this point is a S. Then we'll get Vs minus V naught by feedback resistance, that is a RF. Okay. If in case of Vs also becomes to zero, then you can observe when for large gain, for large gain Vs is equal to 0. Then you can rearrange this equation. I'm writing here. Then CV1 by dt is equal to minus V naught by RF. Minus V naught by RF. So from this you can calculate V naught is equal to something. V naught is equal to minus CV1 by dt. CV1 by dt only. Wrong. Even the RF also there na. Cross multiplication RF CV1 by dt. RF CV1 by RF CV1 by dt. Okay na? This is a V naught. Check it once. Yeah, that much only. Output voltage. RF is a feedback resistor. C is the input capacitor. No done. Yeah. Next one, it is useful in the practical point of view. Signal changes in the amplifier will observe in the signal changes in the CRO, cathode ray oscillator. In that one, we'll observe the practically square wave converted into sine wave, or sine wave converted into ramp wave, or a ramp wave converted to some other wave. ఆ వేవ్స్ చేంజ్ చేయడంలో ఈ డిఫరెన్షియేటర్ ని యూజ్ చేస్తాం. Both the stability and high frequency noise problems, when you are observing in that, we can change the వేవ్ ఫంక్షన్. అంటే సరే అది సైన్ వేవ్ కావచ్చు, లేదా స్క్వైర్ వేవ్ కావచ్చు, లేదంటే ఇంకేదైనా ర్యాంప్ కావచ్చు, ఇంకేదైనా కింకింగ్ పాట్ లాగా, ఇది ఎనీ కైండ్ ఆఫ్ థింగ్స్. సో ఫర్ దట్ పర్పస్ విల్ యూజ్ ద changing of the signal purpose, will use differentiator only. In that condition, we'll apply two components. One is resistor and capacitor in series in input. In feedback condition, we'll use resistor and capacitor in the parallel. Okay, that thing it can be useful in the practical, not in theory. So leave that page 164. Next 165, that is it can be useful in 5 marker purpose, basic comparator. The basic comparator purpose, you can use the two diodes in the reverse order in the input combinations. Sorry, input terminals, not combination, input terminals. The two diodes are connected in reverse order in the input terminals. There we'll observe whether we are observing or we are changing the values in the comparison conditions. Sine ని స్క్వేర్ వేవ్ గా, స్క్వేర్ ని సైన్ వేవ్ గా అలా కంపేర్ చేయడానికి it can be useful. Once you can see theory part only in your material, page number 165. Comparator is a device. అంటే కంపేర్ చేయడం బేసిక్ చెప్పాలంటే V1 V2 వోల్టేజ్ ని కంపేర్ చేయడమే, సింపుల్ గా చెప్పాలంటే. కంపారేటర్, comparator is a device which compresses signal, sorry, which compares a signal voltage on one input of operational amplifier with known voltage is called as a reference voltage on the other input. That's shown in the figure. Operational amplifier two input terminals ki diodes reverse order lo, one is forward, other one is reverse, like that. Reverse order lo arrange cheste, that is called as a comparator. One is connected to high voltage, other one is connected to obviously 0 volt, 0 and 1, like 0 volt to 5 volt lag, 1 ante 5 volt to 0 ante 0 volt. Okay. A fixed reference voltage, if fixed is at 1 volt, apply to the inverting input, and the other varying signal voltage V1 is applied to the non-inverting input. When V1 is less than V real, the output voltage V0, a story ichchagada chadavandi saripotha. That thing is, in that one input terminals, diodes are connected in the reverse order. One thing is a forward, other one is a reverse. D1, D2 protect the operational amplifier from damage due to the excessive input voltage V1. These two diodes are called as a clamped diodes. అంటే రెండు ఒకే డయాబయాస్ లో ఇస్తే అప్పుడు ఏమవుతుంది, వోల్టేజ్ ఎక్కువైనా డ్యామేజ్ వస్తుంది, తక్కువైనా డ్యామేజ్ వస్తుంది. అంటే ఒకటి వైస్ వర్సా ఇస్తే ఏమవుతుందంటే ఒక ఉల్టా, ఒకటి ఫార్వర్డ్ ఒకటి రివర్స్ లాగా. అంటే ఒకటి స్విచ్ ఆఫ్ అయినప్పుడు ఇంకోటి ఆన్ అయిపోతుంది. అంటే స్విచ్ ఇట్ కెన్ స్విచెస్. So it won't be, it can prevent the damages. So for that purpose they are using two switching diodes. అంటే ఒకటి పాజిటివ్ పల్స్ ని కన్వర్ట్ చేసినప్పుడు ఇంకోటి నెగిటివ్ పల్స్ అలా కూడా చెప్పుకోవచ్చు. ఈ గివెన్ ద క్లియర్లీ ఇన్ ద వేవ్ ఫార్మ్. Square wave form it can converted to square, nothing but sorry, sine wave converted into square wave, or square wave it can converted into sine wave. Okay na, he given clearly same like rectifier type. Sine wave కాస్త square wave గా convert అయింది. Once you can see the waveform, the page number 166. Okay na, that's it. In this chapter also this much is enough. In this chapter important questions, question number 1 to 4. In this question, in this unit, important questions 1 to 4. Question number 1, question number 2 and 4th one. Okay na, that's it. Is it clear? Next we'll go to next unit. Okay. Yes. Then we can go to next unit number 12 after this. Yeah, I'll start here. Next you can go through it. Next unit, 12th unit. That's the operational amplifier non-linear applications. The previous one is a linear applications. Now is a non-linear applications. Operational amplifier non-linear applications. Linear applications or non-linear applications. The previous unit linear applications, now non-linear applications. In that first application, off-wave precision rectifier. Oh, this is interlinked with the first block. We know rectifiers in the first block, diodes. Simply two-terminal device, diode means. Or as the sandwiching of semiconductor material together each other. That is called as a p-n junction diode. P-type material, n-type material sandwiching each other properly. That is called as a p-n junction diode. That p-n junction diode applications. First one is a rectifier, the next photodiode, the next LED, solar cell, like that, xenon diode, etc. In that one thing is first one is a rectifier. What is meaning of rectifier? The process of conversion of alternating current into direct current. That is called as, simply you can say, the rectifier. Okay. Again, the rectifier it can classified into two types. One is a off wave rectifier, other one is a full wave rectifier. We know AC signal like this sine wave form only, no? DC signal is a direct, either 1 or 0. That's direct current. This is a sinusoidal current. AC is a. This is a way is a propagation line. This we can say the positive pulse. This is a negative pulse, and goes on. If only this positive pulse or only negative pulse converted AC to DC, that is called as a half of the wave is converted AC to DC, that is called as a half wave rectifier. HWR, my bad. HWR. If in case of both the pulse, positive and negative pulse converted AC to DC, that is called as a full wave rectifier, FWR. There we converted with the help of diodes. But in this unit, we have to convert the AC to DC half of the pulse with the help of operational amplifiers. That is come back to here, operational non-linear applications. In that one, first one is a half wave rectifier with operational amplifiers. Okay. Yeah. Okay. Is it okay? While I'm teaching that way, I'm telling clearly unit name, question, page number, everything na. So you can follow rough notebook along with the textbook page numbers. You can make it a fast running notes. It can sufficiently useful. Otherwise, if you say just only movie type, after finishing of a movie, we won't get any conclusion. If you follow my way, then automatically one time revision only definitely will get more than 60 marks in this paper out of 70. I'll give 100% guarantee. Okay, just a second. Done. In that one thing is a half wave precision rectifier. Half wave precision rectifier. That is called as a basic simple thing is we can say the half of the pulse converted AC to DC in the simplest way. Right? Yeah. Now we can take operational amplifier. Same repeatedly logic here. But in the previous condition, this RF is directly connected to output. But here now is connected through the diode. Diode is connected in the forward bias. Forward or reverse, sir? This forward only maybe. Positive, negative, then forward. Which is connected to here load resistance. From that to here we'll get output. One output here ground. This is a V out. Here thing is a V in. One thing is a ground. These two different connection is a V in. Okay. Better you can say this is a R in. Here input AC signal. AC signal like this. Maybe positive to negative or negative to positive. I'm taking first negative pulse, then next positive pulse. Okay. Na? This is A, this is B, or as negative, positive, whatever may be style. Okay. Then rectifier. This is diode is then a rectified diode. One diode is used. Then we'll get your output. DC. DC signal output. It is a discontinuous. This is A. This is a B. Sorry. This is a discontinuous DC pulsative. Now you can observe. Input we are giving AC. We are getting output is a DC pulsator. Okay. This is a input terminal. Now you can apply your input voltage between input terminals V in and this ground terminal. In the previous diodes, that is connected AC source connected to transformer primary coil. These are the rectifier rods. This is a primary coil, secondary coil. Here diode is connected. We'll take output across the load resistance, that is the RL. Same thing here branch. Instead of transformer, we are using here operational amplifier, that is a IC 741 pin number. So this is the input part. Here also in the previous condition we given as a AC, then we'll get here is the output is a DC. So here also we are using one diode with the help of operation amplifier. In the previous one diode with the help of a transformer. So when the input first pulse we are giving negative, then automatically that negative pulse is converted AC to DC. The next pulse, if we connect the positive pulse, then we'll get positive pulse is connected AC to DC. When it is converting negative pulse converted AC to DC, at that moment it won't convert positive pulse. That's why we are getting give the gap. For example, in the waveform you can take here, this is the alternating current AC signals. This is a direct current is a DC. It is a AC input, DC output. During positive off cycle, that is your wish, sir. I consider here the input is a first negative pulse, the next a positive pulse. During positive pulse, then it can converted across the D1 diode, AC converted to DC, that is okay, fine. At next point, negative pulse, it won't convert. It is a empty gap. Why? Because we are taking output only DC only. So positive pulse is converted, negative pulse is not converted. Why? Because only one diode is connected, that will be in the forward bias in the first thing. Or else you can connect the diode in the reverse bias in the next pulsator, that is a converted negative to positive pulse. So negative AC to DC thing on. So finally here only positive pulse are converted in this condition. Here first we are giving negative na. So instead of this positive pulse, only negative is converted AC to DC. The positive it won't be converted. So positive as it is positive. The next negative pulse it can convert it. Next negative pulse it can convert it. So it is the output of DC only now. So finally you can say output is a discontinuous DC pulsator. Output is a discontinuous DC pulsate. Is it clear? Right. It is a discontinuous DC pulsate. It can convert. అది గుర్తుంచుకొని ఇక్కడ ఓవరాల్ గా ఎక్స్ప్లెయిన్ చేసినప్పుడు సరిపోతుంది. In the off wave rectifier, in full wave rectifier you can consider two diodes in the bypass way. In the bypass way means one more resistor is connected here, that is connected to bypass the input. That thing is in the full wave rectifiers. Understanding? Here one diode, the next diode is converted like connected like this. This is a D2 diode, which is converted to bypass lead to the input. Bypass lead to the input. Then both the pulse is converted AC to DC, which is connected here in the input. One time positive pulse is converted AC to DC. The next negative pulse is converted AC to DC. So finally both the pulse converted AC to DC, that is called as a full wave rectifier condition thing. Understanding what I'm saying here? Positive pulse, negative pulse, both the pulse converted AC to DC, that is in the full wave rectifiers. Then output here will get a continuous DC pulsate. Output is a continuous DC pulsate. Output is a continuous DC pulsator. You'll get first A, then next B, then again A, then again B. Alternatively, A, B, A, B, A, B, A, B, A, B, it can get. Okay, na? But this thing no, don't expect in exam. Why? Because compared to here and the operation amplifier, most important thing is conversion in the with the help of diodes only. This is a topic only you can learn, but I'm not expecting this thing in the examination point of. Next one I can expect, sir. Logarithmic amplifier. That one is important. Logarithmic amplifier, exponential amplifier. These two importance. Okay, no? But I'm not expecting this thing. వచ్చినా కూడా no problem. We have so many choice na. 50% choice. That's good చేయొచ్చు easy. But all are easy if you look individually. If you mix togetherly, it can jumble. Be careful. If you mix, it can give a short circuit in your brain. No current flows through the brain. That is called as short circuit only. Yes. Next one is a logarithmic amplifier. Logarithmic amplifier. Logarithmic amplifier. Yeah. Okay. Log function. ఇంటిగ్రేటర్ అన్నప్పుడు ఇంటిగ్రేషన్ చేసాం, డిఫరెన్షియేటర్ అన్నప్పుడు డిఫరెన్షియేట్ చేసాం, లాగరిథం ఫంక్షన్ లాగ్ ఫంక్షన్ అప్లై చేయాలి, ఎక్స్పోనెన్షియల్ అన్నప్పుడు ఎక్స్పోనెన్షియల్ ఫంక్షన్ అప్లై చేయాలి. దానికి యాంప్లిఫైయర్. ఓకే, ఇట్ బి ఈజీ ఓన్లీ. Let us consider operational amplifier, positive, negative, positive connected to ground, negative connected to, this pin is connected to input resistance, and that input resistance connected to, here junction is a S, here terminal is a V1, this terminal is obviously V2, V2 connected to ground, which is connected to AC source, this again connected to ground. This is a input resistance Rin, this current is a I in. Okay, at the junction again current it can split, again it can current goes through the diode. Yeah, this current is called as a feedback current IF. This diode D1, one diode one thing is positive, negative, nothing but PN reasons. This is connected to the output. You can do yourself once practice, then it'll be easy. Okay. One second. Someone sent message rectifier definition. Just now I saw that message. 1 minute, keep in hold this topic. Go back to rectifier. Easy only, simple word. The process of conversion of AC to DC. Very simplest way. The process of conversion of AC to DC is called as a rectifier. Okay. Yes. Now come back. Logarithmic amplifier with help of operational amplifier. With help of operational amplifier. We know, I think, 1 point in degree level exponential current across the diode relationship, voltage equation or current equation. I is equal voltage and the current and charge also. Decay of current, growth of current. This will be there, I think, in third year only, third paper. Growth of current, decay of current, growth of charge, decay of charge across the resistor and capacitor things. అది తెలిస్తే ఇక్కడ ఈజీ అవుతుంది. Otherwise, we have to go back to degrees level and we can observe the derivation part. After doing lengthy part, we'll get one equation, that is I is equal to I naught ఇంటూ ఈ పవర్ మైనస్ వి సంథింగ్ అని వస్తుంది. వి టౌ బై సంథింగ్ సంథింగ్ అని -1 అని ఈక్వేషన్ వస్తుంది. దట్ ఈక్వేషన్ వీ హ్యావ్ టు రిమెంబర్ హియర్ డైరెక్ట్లీ. ఓకేనా? డన్. సో current across the diode. This equation we have to remember from previous years. That is IF is equal to I naught, peak current, into e power 1 minute. You can take it. Yes, the number. Sorry for the delay. You can check it once. Where we are right now. Logarithmic amplifier. Logarithmic amplifier. In this one, diode is connected. That's current is I is equal to I naught exponential power. Nothing but e power. VR by the feedback voltage. The resistor voltage. VR by neta into VT. VR by neta into VT. Minus 1. Capital T. Minus 1. Okay. This thing is. This is a current across the feedback diode. Neta is a it is constant now. Unity of okay, my bad. VT is a voltage equivalent of temperature. Neta is a actually we consider in the previous one is a efficiency of the diode. Neta is a efficiency of the diode. VT is a voltage equivalent temperature. Voltage equivalent temperature. Okay, done. Then we can take it as two conditions. If you restrict the operating region of VR, this entire value more than of one on condition only it can possible. Okay, now. If you restrict the operating region of VR, that value, this entire value greater than of 1. The entire value greater than of 1. If you can say e power VR by neta into VT greater than 1 or greater than much greater than 1. Better. ఎంత వాల్యూ ఏజ్ లా చూసుకుంటే అంత బెటర్ నాష్ -1 sorry greater than 1, then we'll get IF greater than I naught. IF greater than I naught. Now you can apply both the sides logarithmic functions. Log IF greater than log I naught. That value we can take it as in terms of voltage. So logarithmic relation may be expressed as taking both the sides log function. Then we can say the thing is here log IF ln తీసుకున్నాడు ln ఫంక్షన్ కి log ఫంక్షన్ కన్వర్ట్ చేస్తే అప్పుడు మనం ఏం చేస్తాం 2.03 తో వేసుకుంటాం కాబట్టి బెటర్ యూ కెన్ సే డైరెక్ట్లీ ln IF is equal to ln I naught plus additional in terms of voltage VF by neta into VT. Neta into VT. So from that you can calculate VT value. Sorry, VF value now. Voltage across the diode. Which voltage? Feedback voltage. Feedback voltage across the diode thing on. One second. Then you can send this side ln IF minus ln I naught is equal to VF by neta into VT. Log A minus log B. Log A by B. So ln IF by I naught equal to VF into by neta into VT. So from that you can say VF is equal to ln IF by I naught into neta VT. Okay, no? That is called as a voltage across the feedback diode. Voltage across the feedback diode condition. Similarly, we can see exponential function. It is a logarithm function in terms of log only. Exponential function it can take in terms of exponential exp. That is the next one. Is it okay? In the exponential function purpose, one second in your page number, in your material page number 174. 174 page. What is that? Exponential amplifier. So in this one, we have to use transistors. We have to use transistors. That is a coupling of two transistors. We have to use here coupling of two transistors. Once you can see in the page number 174. This coupling of two transistors connected through the operational amplifiers. Okay, na? One thing is a T1 transistor, other one is a T2 transistor. Both the transistor they are using common emitter configuration transistors only. Common emitter configuration transistors. Okay, that one thing is amplifier for first transistor. Second one is in the output connection connected to the operational amplifier. Once you can check the diagram part. Okay, na? The circuit diagram one is a virtual ground is given. Transistor three terminals emitter base collector that three connected as shown in the figure. From that you can calculate current both the cases. Collector terminal current IC1 IC2. From that you can say Ohm's law V is equal to IR, then I is equal to V by R. Then IC1 is equal to VR by R2, IC2 is equal to V0 by R2. Okay, na? From the input terminals we can say V is equal to, from the diagram, R1, R2, R3 resistors are given. Na? For input condition bypass, that is what we can say is two resistors, R3 and R4. These two are resistors given in the input terminals. In that one, we can calculate voltage. V is equal to R3, V3 by R3 plus R4. That is nothing but Vt into log n as log, nothing but Ln function. IC2 by IC1. The substituting of current IC1, IC2 value will get equation in terms of log function both the sides. After log function, you can apply both the sides exponential function. You can take exponential function both the cases, both the sides. That log function, exponential function, it can cancel. We'll get finally that output voltage in terms of V0 is equal to R1 VR by R2 into exponential function the e power minus Vs by Vt into R3 by R3 plus R4. This is called as a exponential amplifier explanation part. Once you can see that steps, from the books only. Next one is the last one, differential amplifier. Nothing but difference only. In that one is a voltage gain. Again, differential nothing but difference only. VD is equal to V1 minus V2 only. Inverting pin, non-inverting pins across the resistor R1 and R2. They given the connections. We have to observe it. Okay, na? The thing is, RF is a feedback resistance. That connection will be easy. I think we can observe operation amplifier positive, negative connected to input resistance and output connection connected to feedback to the input terminals. That is the RF feedback resistance. Okay, na? V01 is equal to minus RF by RI into V1. From that one also you can observe mathematical part also will be easy only, I think. Just you can calculate voltage divider rule only. Sorry. You can apply voltage divider rule only both the cases. The voltage divider rule, you can find out V value. Is it okay? I'm not writing this part on the board. You can observe from this book voltage gain value, previous one exponential amplifier. These two things you can observe here only. The next one more unit is there. That is a operational amplifier waveform generator. Means that is thing is conversion. Square wave to sine wave to triangular wave, any other that different wave conversion purpose. Better this conversion process we'll do in the next class. Then we can go to back to first unit in the next two more classes. Next weekend, Saturday and Sunday, we can try to discuss again first block. ఆ 2 days లో పోజమైనంత మట్టుకి ఆ ఫస్ట్ యూనిట్ ని థియరిటికల్ పార్ట్ ఎక్స్ప్లెయిన్ చేయడానికి ట్రై ఇదటో అయిపోతుంది 13th యూనిట్. It can finish in the next class with full energetically. It can finish hardly in first 10 minutes. Then next we can go to back to first unit in the next coming 2 days. So officially classes they can finish in the next weekend only. Saturday and Sunday last two classes. After that, if not yet finished, I'll take one or two extra classes. I'll try to finish remaining part and doubtful parts. So before that, you can go through it yourself. Only most important selected questions only enough. No need to study entire the book. Your way, you can go through it examination point of view, question to answer. If you want to get score, if you want to get the practical knowledge, once you can read entire the textbook part, it can sufficient. Is it okay? Yeah. Okay. If any doubts, you can message here or else you can speak one by one. Then we'll do further next class. Yes. Is it okay? From this topic, if you have any doubts, you can text your message. Otherwise, we'll stop here only. Then we can continue that last unit, 13th unit in the next class. Then we can go to next. Yeah. Is there any queries from your side? If it is there any queries, I'll give the reply here. At least 7 students are there now. Yes. Okay. Then okay. In that logarithmic amplifier, someone is said about logarithmic amplifier. One place model. Okay. I don't know your name now. I'm reading based on that Zoom app name only. One place CPH something. One place mobile. Okay. They're saying logarithmic amplifier. The thing is logarithmic amplifier. Just you can take the diagram in the instead of feedback resistance. You can take the diode, and here there is a current exponentially functions. Growing of current equation, and we know in the previous years, not in this year, previous year, degree at intermediate. I is equal to I naught e power exponential power something minus 1. That is a here VR by neta into VT. Neta is a here efficiency of diode. VT is a voltage temperature. So if if this part exponential value is a more than of 1, greater than of 1, then the value will get IF greater than I naught. Then both the sides you can apply exponential functions, will get log IF equal to log I naught plus for this voltage part VF by neta into VT. After that you can solve the equation, you will get VF is equal to log IF by I naught into neta VT. That is a exponential function. Sorry, logarithm function. అంటే బేసిక్గా చెప్పాలంటే లాగారిథం ఫంక్షన్ లో ఫైనల్ ఈక్వేషన్ ఇన్ టర్మ్స్ ఆఫ్ లాగ్ లో ఉండాలి. ఎక్స్పోనెన్షియల్ ఫంక్షన్ కి ఫైనల్ ఈక్వేషన్ యూ హావ్ టు ఎక్స్ప్రెస్ ఇన్ టర్మ్స్ ఆఫ్ ఎక్స్పోనెన్షియల్ ఫంక్షన్. సమ్ అదర్ ఫంక్షన్ కి ఏ ఫంక్షన్ మెన్షన్ చేస్తే ఆ ఫంక్షన్ నేమ్ లో ఉండాలి. ఇక లాగారిథం ఫంక్షన్ కాబట్టి ఫైనల్ ఈక్వేషన్ ఇన్ టర్మ్స్ ఆఫ్ లాగ్ ఆన్, లైక్ దట్. ఓకే, రైట్. నెక్స్ట్ ఎనీబడి? Is there any queries next? It's okay, na? Page number 173. What is that? Page number 173. I'll see 1 second. There is no need. Page number 173, no need. One place mobile, page number 173 is not required. Up to here only exponential logarithm function is enough. Okay, right. Very good response. Yeah. If you any doubts anytime while you are going to preparation time, if any doubt, just you can send the page numbers in the WhatsApp, or else the questions what are maybe related to this paper. I'll explain anytime. Based on my free time, I'll call back you in the WhatsApp. Thank you so much, sir, for brief explanation. One plus. Thank you. Okay, read well, get better score in our paper compared with the other 3 papers. Last is best type. You can feel and you can try to get better score in our subject. Yeah, only few days only, hardly one calendar month. 9th onwards exams only start. Today's date is the 7th. Hardly 30 days only. You can split one block, 1 week or 2 weeks like that. Okay. Right. Bye. I'm leaving here only meeting. Then we can update in the coming Saturday, same time, or any other time. I'll update in the WhatsApp. Okay.
Okay, sir. Thank you very much.